Hello, here we're doing chapter 13, vector applications. We skipped section A in the textbook, now we're doing section B. 13B, using vectors to represent lines. So let's think back to what we already know about representing lines using linear functions. If we think about y equals mx plus b, where m is the slope, and it equals delta y over delta x. We could determine the slope of a line. Let's take this blue line that we have here. We could determine the slope of it by taking any point, starting with any point, then going to any other known point, taking the difference in the y, which is down 3, difference in the x to the right 2. So in this case, that is down 3, so negative 3 for the y, delta y, to the right 2, so positive 2 for the delta x. So therefore, that slope is negative 3 over 2. Okay, this is the y-intercept. So we can just go and look at the y-intercept. 1, 2, 3, 4, 5, 6. It's at 6. In this case, so therefore the equation of this line is y equals negative 3 over 2 x plus 6. Okay, now, so that's from the past linear functions. We all know how to do that. If we could not see exactly what the y-intercept was, we could take any other point on the line. Let's say we knew this point here, and it is 2, 3. We could have substituted that point 2, 3 in for x and y to calculate b. Okay, linear functions, you all know how to do that already. Now, let's think about using vectors to represent lines. When we're using vectors to represent lines, the r will end up being any point on the line that we're trying to figure out. Okay, a is a fixed point on the line, one that we already know. So for example, 2, 3, this point right here, then we could say this point in vector form, or the position vector of that form, the vector that would start from the origin and go to that point 2, 3, would be this vector 2, 3. Okay, t is the variable in this case, and usually it will be time. B is the direction vector. Direction vector. Now, the direction vector is related to the slope of a line. Direction vector and slope have some sort of relationship. I want you all to make sure you know this relationship. The direction vector is actually delta x, delta y, represented as a vector. Okay, so really it's the reciprocal of the slope. Okay, so that's the connection between the two. All right, so if we were to represent this line using vectors, we could use this as our fixed point. We could also choose any other fixed point that is on that line. If here we could have chosen 1, 2, 3, 4, 4, 0. So we could choose that as our A. Up here we've got 0, 6. So we could have chosen that as our A. Okay, so therefore there's many, many ways we could represent the equation of a line using vectors. That's what we mean when we talk about the non-uniqueness of a line. Okay, so in this case, I'm going to use this one though, 2, 3, as my A, and my direction vector, I'm just going to use as to the right 2, down 3. So my direction vector is going to be 2, negative 3. And therefore, this equation then would be r equals 2, 3. That represents the fixed point on the line, this one here, plus t, which is our variable, which would usually be time, and the direction vector 2, negative 3, which is the direction this way. Now, another direction, because a line goes in both directions forever, we could have chosen the other direction. So we could have said, oh, from here, I'm going to the left 2 and up 3. So we could have said negative 2 3 as a direction vector and substituted that direction vector in, just to the opposite direction. Okay, so several ways we could represent that equation. In y equals mx plus b form, there's only one way, but in vector form, there's several ways. We could have several different fixed points, and we could have several different representations of the direction vector in either direction or in a different size. Different size could mean if I'm going directly from this point all the way down to this point, then that would be to the right 4, down 6. So we could have said 4, 6 here, 4, negative 6 here for our direction vector. So many different ways to represent the equation of a line using vectors.